Hello, I'm going to show you the new FFB Graph system. At the top here, we have it displaying the current FFB graph, and I have it showing the built-in Marvin's Awesome graph. The middle section here shows the settings of the currently selected node. So if I change this currently selected node, this part will change. For example, if I select the low pass filter node, it's now showing the option for that node. Some nodes, like the add node, does not have any option. It just got an enable and disable switch. The preview graph down here also shows the inputs and outputs of the currently selected node. Input number 1 shows as red. The output shows as a white line. If you select a node with multiple inputs, like this one, input number 1 would be red, and input number 2 would be green. If you want to adjust the settings of one node, but have the preview graph show a different node, you can do that. For example, if I wanted to change the settings of the gain node, but look at the preview of the output node. So what I do is I'll right click on the output node. Now the preview graph is showing the output node, but my settings are still showing the gain node. So now I can adjust this setting and it will show what it looks like at the output at the very last stage here. I'm going to show you how to create your own FFB graph from scratch. You can click on the plus icon here, give your graph a name, and then click on Start Empty Graph. If you wanted to make a copy of the graph, you can pick Clone Current Graph instead. So this is now a brand new graph, and it's just got the 360 hertz source and an output. I'm going to show you how to add a node to the graph. So you click on the plus here inside the node graph window, and this is a list of different FFB modules you can add. I'm going to add the 60 hertz source one just for an example. And you can tell the difference between the 60 hertz source, which has a lot of staircasing, and the 360 hertz source, which is smooth. To change how nodes are connected, all you have to do is mouse over an input or output and drag to make a new connection. So now output is connected to this 60 hertz input, and it looks like this. I can reconnect it to the 360 hertz output source node, and now it looks like this. To delete a node, all you have to do is click on it, and there's a minus button that you can click on, and that gets rid of it. You can insert a node in between two connected nodes just by clicking on the node you want to insert after, then selecting a new node, and it automatically wires it up for you. And if you delete it, then it'll rewire it for you as well. So I'm going to delete the gain node, and now it's all wired up nicely. I'm going to show you what each node does. Okay, so I'm going to start with the gain node. This is really just a multiplier. So the gain is currently 1, which basically means it does nothing. I can increase the gain and decrease the gain. You can also flip the signal around by using a negative gain. This is the compressor node. Basically what it does is it compresses signals above the threshold. So if I lower this number here, you can see the effect. Anything that's above 9.3 Newton meters gets compressed. You can change the knee, which is basically the width of the ramp up for the compression, and the compression ratio. Now I'm going to show you the high pass and the low pass filters. I've just put in a high pass filter. You can select between a 1-pole and a 2-pole filter. Basically, what the high pass filter does is that it removes the low frequency signal and leaves only the high frequency signals behind. So that's why it looks pretty flat. It's only showing the basically the noise in the signal. I'm going to add a low pass one. And it's basically the opposite of the high pass filter. It removes all the details and leaves only a smooth curve behind. Now, I could set these two to the same frequency. And I can add an add node. Now, if I switch between showing you the add node, which adds these two together, and the 360 source, you'll see that the signal is exactly the same. Look at the white line. It doesn't change. What I'm doing is I'm splitting the signal out into a high frequency and a low frequency signal and recombining them to get exactly the same thing back. Now, what I can do with the high pass filter here is I can add a gain node right after that. Now, let's say I'm going to put it like a 3 times gain. So you'll notice that it's increasing the details. So if I right click here, I can see the result of changing the gain. Now let's say that when I'm parked, I want to have the steering wheel center itself and basically ignore the standard force feedback from iRacing. I'm going to show you how to build that. So I'm going to start with adding the wheel centering force. All right. Now you'll notice that it's pretty gritty here because the wheel centering source is based off of iRacing's steering wheel angle, and it only gets updated at 60 hertz, not 360 hertz. So yeah, okay. So what I can do is I can add a smoothing filter right after that. I'm going to also add a gain filter so it's easier to see what the smoothing filter does. You'll see a lot of staircasing here. And I have the smoothing filter turned off right now. So as soon as I enable it, you'll see the staircasing goes away. That makes the wheel centering feel a lot smoother. What I'm going to do next is I'm going to wire the wheel centering into the output. But what I want to do is I want to make it speed dependent. So that the wheel centering only takes effect when I'm parked or moving at a very slow speed. So what I'm going to do is I'm going to add a new effect called speed gain. It's basically the same as a gain control here, except it's based on speed. So you have basically two different speeds. You have a minimum speed and a maximum speed. So let's say that I want to have the wheel centering force be at maximum strength at minimum speed, and then go away completely at maximum speed. So I'm going to change this to 0. And a way to test this out is by default, it shows what the output looks like at maximum. But if you wanted to have it show you what the output looks like at minimum instead, you can push the test button here, and this is at minimum. So showing the white line here is active at minimum and completely flat at maximum. I'm going to add another add node here and then wire this in. So now what's going to happen is that at slow speeds, it's going to automatically try to center my wheel. What I'm going to try to show you next is curve protection. So the idea behind curve protection is that you want to cut down on the high frequency details anytime you run over curves so it doesn't break your thumbs. What I'm going to do here is I'm going to add a curve protection node right here. And now you can see this yellow area is curve protection kicking in. And if you look at the numbers, you'll see that in the pop-up where it says the shock velocity, you see it 0.68 right here. And depending on where you put it, it's like 0.47 here, 68 here, whatever. And if you change this, you're actually making it more sensitive or less sensitive. So here's a good spot to look at. So here, I'm basically saying if my shock velocity goes above 0.3, trigger curve protection. And I want to reduce the forces by 75%. So you can see the white line is a lot less than the red line, red area here. If I set it to 0, it basically turns curve protection off. So I'm going to set it to like 1%. You can see the white line goes all the way up to where the red part of the graph is. Then I can reduce it some. You see the white line is a lot less here. So it reduces the forces so the steering wheel doesn't become too violent. And if I look at the graph before this and after this, I can actually tune it so it feels the same amount all throughout the corner. And this recovery time, what it does is the time it takes to ramp back up to normal force feedback. So I can increase it or decrease it. So to make it really obvious, I'm going to set force reduction to 100%. So you can see it's completely flat all the way through for, let's make it 0.25. So for a quarter of a second, it's going to be completely flat. Then start ramping back up to normal strength. And if I set it to 0, you'll, let's see. You'll see that the white line jumps back up pretty abruptly. That's your normal force. You really don't want to do that. You want a bit of recovery time so it ramps smoothly back up to normal forces. I'm going to show you how to add on crash protection now. The best spot to do it would be right after I recombine the high and low pass filters together. Whoops, wrong spot. All right, so when I made this recording, I did not crash the car. So it's not going to show anything relating to crashes here. What I'm going to do is I'm going to lower my lateral G-force trigger all the way down. And maybe that'll bring something up. Oh yeah, there it is. Okay. So when I was at this spot on the track, my lateral G-force was 2.1 G. So it's triggering crash protection. Crash protection shows up as orange. And the idea is that it works the same way as curve protection. You have a duration. You can increase or decrease how long it stays on. Then you have a recovery time. Sorry, that's force reduction. Recovery time here, how long it takes to ramp back up to normal forces. Then force reduction here is how much to reduce the forces when it detects the crash it. This video is already getting pretty long, so I just want to show you one more thing. I want to show you a new effect that was never in the app before, and it's called torque dither. Okay, so this is ideal for low-powered steering wheels, such as the Logitech G29. If you have such a wheel, what would happen is if your wheel is centered and there's not a lot going on, the wheel's going to feel pretty dead. Because of the way it works, the center of the wheel is the worst spot. So what the torque dither does is whenever your wheel is close to the center, like there's no forces going on, it'll actually add some random noise to basically make the wheel feel alive and working while the forces are centered or when your wheel is centered. The first setting is how much noise to add. And the second center is controlling how close to the center does it need to be for the effect to kick in. I do want to add one more thing. I want to show you the LFB source. So I'm going to add it here. And this is the low frequency effect source. And you can see the LFB data right here. I'm going to go back to your crash protection and reset that. And curve protection, reset that so it doesn't make my graph or the preview window ugly. Okay, so this is the LFB source. What I want to do is I want to put a gain, where are you? Gain module right after that. And cut the LFB down a bit. So subtle. You don't want it to be too aggressive. You want it subtle. And then have a add node right after that. And let's see, I guess the best spot to add it would be about here. So now I'm going to increase the LFB just so it's a lot more noticeable. So this is a lot of LFB. So if I look at the output, you can see all the LFB signal getting blended in. So I'm going to click on the gain, then right click on the output. Now you can see how I can control how much LFB. About 0.2, 0.3 would be good. If you ever want to share your graphs with other people, you can export it by clicking on this button here. Just give it a name, and then just copy the file over to Discord or whatever. And then that other person can click on the import button here and then import your graph. So if you make something cool you want to share with other people, that's how to do it. And I think that's the end of this video. I hope this video helps you try to figure out how to use this new system. And please give me feedback and let me know if something doesn't work. See you around.